Alright, continuing in our integral unit, we're going to be looking at finding definite integrals today. So remember from last lesson, when you're finding a definite integral, you are finding the area under a graph. And so we've got some function here modeling the velocity in feet per second of some person riding an off-road Segway, some t seconds from some starting point. We have the graph of it shown right there, and we want to know how far did that dude travel between time t equals 3 and time t equals 6. Well, think about what we're doing. We're taking a velocity function here, v of t. If we integrate the velocity function, we end up with position. Specifically, to find the distance traveled between time t equals 3 and time t equals 6, we're looking at the area between those two x values. So we're looking for that area right there. So there's a couple different ways we could do this. What I'm going to do in the beginning is I'm going to look at this as triangles. So picture this giant triangle right there, that whole thing. If I took that triangle and subtracted away this purple triangle, I would end up with that pink section right there. So take a look at my lovely color coding right there. Green squiggle minus purple squiggle equals pink squiggle right there. We're looking for pink squiggle, the area under the graph of our velocity function between times t equals 3 and t equals 6. That represents the distance traveled between those two times. And so I'm going to be looking at two different triangles here. Green triangle, my base is 6. Times the height is 3, so 6 times 3 divided by 2. We're taking that, and we're going to subtract from that the area of the purple triangle. Base is 3, times the height there is 1.5, so let's say 3 halves right there, and then divided by 2. And that's going to give us our pink area. So let's simplify this a little bit. 6 divided by 2 is 3, so we have 3 times 3 gives us 9, minus, let's look at what we have. 3 times 3 is 9, divided by 2, and divided by 2 again, and so we end up with 9 fourths. So 9 minus 9 fourths. Let's get a common denominator there to find our pink area. So 9 times 4 is 36 over 4 minus 9 over 4 equals that pink area. 36 minus 9 is 25 over 4. So that person traveled 25 fourths feet between times t equals 3 and t equals 6. Well, what is it really? 25 fourths. Well, how many times does 4 go into 25? Well, 4 goes into 25 6 times. So we're getting 6 and 1/4. 6 times 4 is 24 with that extra 1/4 there. So this guy traveled 6 and 1/4 feet. Well, let's look at that another way. We also know that that pink area is a trapezoid, and so I could figure out this area by taking it as a trapezoid. And this is the trapezoid we're looking at with the height, the first base, sorry, not the height, but the first base being that left side right there, which is 3 halves. The second base being that height at t equals 6, which is 3. And then the height of this triangle, this trapezoid, I cannot speak, the height being that distance right there, the distance between the two parallel bases, is also 3. And so we get our formula to be the average of the bases times the height. And we can simplify that from there. 3 plus 3 halves, 3 plus 1.5, so we're going to get 4.5 over 2. 4.5 over 2 is the same as 9 over 4. So I have 9 over 4 times 3, which gives us 9 times 3 is 27 over 4, which actually just allowed me to notice I'm bad at math up here. 36 fourths minus 9 fourths is 27 fourths, not 25 fourths. I did some bad mental math. And so we don't end up with 6 and 1/4, we end up with 6 and 3/4, so 6.75 feet. Same number we're getting if we treat that area as a trapezoid. So two different approaches to finding that same area right there. So our plan for the day is essentially that. We're going to be sketching some graphs of functions, and we're going to be using those sketches to find definite integrals, area underneath the curve. So let's go ahead and do some practice real quick. Here's a graph of f of x. We want to find the definite integral from x equals 0 to x equals 8 of this function f of x. And so we're looking for this entire area right here underneath the graph. Notice this is an absolute value function, but really we're just ending up with two separate triangles right there. So let's find those areas real quick. First triangle, look, we have a base of 3, a height of 3, and so that area is going to be 9 halves. Plus our second triangle, we have a base of 5 and a height of 5. And so now we're ending up with 25 over 2. So when we add those areas together, we're going to get 34 over 2, which is 17. And so the definite integral from 0 to 8 of the function f of x is 17. But let's, just for practice, write this equation. So you should recognize that the mother function here is the absolute value of x, and let's look at these transformations. It has been shifted to the right by 3, and if you look at the slope on both of those lines is 1. As we go over 1, we go up 1, or as we go over 1, we go down 1, depending on which branch you're on. But the point is, that means we have not multiplied this function by anything. All we've done is shift it to the right. And so our function is f of x equals the absolute value of x minus 3. Remember, subtracting the 3 right up with your x like that inside of your function, that will move it to the right by 3. Alright, let's do another one. The graph of g of x is shown below. Find the definite integral from -3 to 3 of g of x and write the equation of g of x. Well, recognize that this is a semicircle. The equation of a semicircle will be g of x equals the square root of the radius squared. So look at your radius. Your radius is 3. So it's our radius squared gives us a 9 minus x squared is that function right there. Now let's find the area there. Well, that is a semicircle, which means we're going to use our equation for the area, which will be pi r squared over 2. I'm dividing by 2. Sorry about that. I'm dividing by 2 because it's a semicircle and not a full circle. And so the integral there is going to represent that semicircular area with the radius of 3. So my area will be pi, let's just say times 3 squared over 2, which will simplify down to 3 squared is 9. 9 pi over 2 is that area right there. Alright, one more absolute value graph this time. This time it is upside down. Let's write that equation. This is going to be h of x equals, notice it's upside down, so we're going to end up with a negative absolute value of something. X, it's been shifted to the left by 2, which means x plus 2, but it has also been shifted up 3, so we need to add 3 to the end of that function. That should be a good representation of h of x right there. And now we're finding the integral from -6 to positive 2. And so recognize that we have these two negative areas right there underneath the graph, between the graph and the x-axis. And then we have this entire positive area right there. So let's figure out those individual areas. Well, here is a triangle with a height there of 3. And what is the length of that base? Well, the length of that base appears to be 6. And so I get 6 times 3 is 18, divided by 2 is 9 for the green area. And then I have those two purple areas, which are triangles as well. Base 1, height 1. And look, there's 2 of them. So I would be doing base times height 1 times 1 divided by 2 and getting 1/2, but there's 2 of them, so I know that's a total of 1. And you can just tell also by looking at the grid here. But if we didn't have the grid, we would still be able to figure it out using those formulas. And so we get 9 minus 1 gives us our total definite integral of 8. Alright, well now let's do one without having the actual graph here. We want to find the definite integral between 1 and 4 of this function, 2x plus 3. So let's sketch a quick graph of it and see how we can find that area. So, first off, things I know that it's starting at the y-intercept of 3. Because of that, because of that plus 3 right there, so I know that is my starting point. And then I know that my slope is 2. This is a linear function, which means I'm just going to plug in to figure out where these points of interest are. What do I need? I need the point 1 and I need the point 4. Well, the first one should be no biggie to get. The slope is 2, so I should be up 2 from there to get my first point right there, which we know is 1, comma 5. So there's 1 point on there that we know for sure. And we know our graph's going to be going up linearly like that, and we want to figure out where does that end up when you get over here to t equals 4. Wow, that's totally not to scale. So let's say 1, then let's say 2, 3, 4. So we want to know what is this point right there, 4 comma something. What's that y value? Well, plug it into your equation. 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. And so we know that's the point 4 comma 11 right there. And we want to find this integral from 1 to 4. So we're dealing with this trapezoid right here. So let's figure out that base right there is 5 because we found that point. This base right here is 11 because we found that point. And now the height is between 1 and 4, which is 3. And so if I want to find this area, all I need to do is say 5 plus 11 over 2 times 3. 5 plus 11 is 16, over 2 is 8, times 3 is 24. So the value of this definite integral is 24. Alright, same thing. We want to sketch this graph and then calculate the definite integral here. So we're graphing the absolute value of x minus 2 minus 1. Well, what does that minus 2 do? That minus 2 is going to shift it to the right by 2. What does that minus 1 do? It's going to shift it down by 1. And so, draw our axes right here, right 2, 1, 2, down 1, 1, right there. We know the coefficient out front is 1, which means each branch is going to have a slope of plus or minus 1. So if we go over 1, we should go up 1. As we go over 1, we should go up 1. And so we're getting that linear branch right there. Let's do the same thing in the opposite direction. Over 1, up 1, over 1, up 1. Right there. But we need to go all the way to negative 3. So let's keep going over and let's keep going up until we get where we want to be at negative 3. Boop, 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 boop. Doop, 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 boop, boop. There we go. And let's sketch this in. Doobie 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 doop. Kind of crooked, but not so bad. Doing it freehand, whatever. What area are we finding? Well, we're finding the area from negative 3 to positive 3. So there's negative 3. We have this point right there, which is negative 3, comma, what is our y value? Well, 1, 2, 3, 4. So negative 3, 4 right there. We have this point right here, which is 1, comma, 0. We have, keep talking, this point right here, which is 2, comma, negative 1. Here's another useful point for us right there, 3, comma, 0. So I'm finding this positive area right there, fill all of that in all the way over there, and then I'm going to be finding this negative area right there, all the way up to that x value of 3. So positive area, well that's going to be this giant triangle right there, base right there of 4, height of also 4, and then I have this pink triangle right there, which if you can picture the height of this triangle as that bit right there, that height is 1, and we have this base is 2. And so the purple area is going to be 2 times 1 over 2, so that's going to be 1. But it is below the x-axis, so we will be thinking of that as a negative area right there. And so then this green triangle is going to give us a 4 times 4 over 2. So 4 times 4 is 16, over 2 is 8. And so then my total area is going to be 8 minus 1 equals 7. Alright, maybe those two were easy for you. Let's do one that's maybe not quite as easy. So we want to sketch this graph h of x and calculate the definite integral from -9 to 0 of h of x. And what do we have? Well, we have this weird square root, square minus squarey thingy, but remember that that is the equation of a circle, or really we should say a semicircle. It is the radius squared minus our x squared term, but look, it's negative out front and it is shifted up 9. And so if we sketch this, the fact that it's negative means the semicircle is going to be upside down like that, like a turtle on its back. The 81 tells me that the radius r is 9, and then the plus 9 is telling me that it's being shifted up 9. So normally if it was negative like that, it would be down like that, but we're taking it down and then we're shifting it up, so it's going to end up there like that. And so let's actually plot this in as we want to see it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what do I know? I know it's upside down. I know that the radius is 9. I know it would be having its two endpoints on the x-axis, but we're shifting everything up 9. And so those points are all the way up there, all the way up there. And I know that that point is now right at the origin. So this is going to curve down like that. And that's as good as it's going to get. I'm not going to be able to draw a better semicircle. But remember, we are integrating this function, which means we're finding the area underneath the graph, between the graph and the x-axis. So we are looking for this entire area down here. We're essentially looking for the wooden part of the half pipe right there. And so how are we going to do that? Well, that's a good question. I could figure out this purple area right there. I could figure out that area because that is a semicircle with a radius of 9. And I could then subtract that from the entire rectangle right there to figure out that pink area. So again, I'm going to say squiggle green minus squiggle purple equals squiggle pink. And so let's crunch those numbers. Well, what do we know for the area of the green piece? Well, it is going to have a distance there of 18, because I know the radius, I'm trying to write here, but I can't. I know the radius is 9, so that whole distance is twice the radius, aka the diameter, which is 18. And I know the height there is that radius, 9, so we get 9 times 18. Well, I don't know how to do 9 times 18 in my head, but I know that 18 is 9 times 2, so this is the same as 9 times 9 times 2, which is 81 times 2, which is 162. Yay for math stuff. Alright, well that's the green area, and I need to subtract away that purple area, which is the area of that semicircle. So again, area of a circle is pi r squared, so a semicircle is pi r squared over 2. And so we're going to get r squared, r is 9, so we're going to get 81 over 2 pi. And so now we need to take 162 minus 81 pi over 2 to get our answer of... Oh, but did you realize I messed up? We were finding the integral from -9 to 0, so we actually only need half of this, so let's just divide all of that by 2 once we get our answer, and then that will give us just the pink part. So let's scratch off that black part because we don't want it. We only want that fully pink area right there. So 162 minus 81 pi over 2, that would get you 34.766, and so we're going to divide that in 2, and we'll get roughly 17.383. So let's look at a similar idea here, but a slightly different problem. The graphs of f of x equals x over 2 plus 3, and g of x equals negative 2x plus 8 are shown to the right, and we want to find the integral between 0 and 2 of g of x minus f of x. So one property of integrals that we can use here is that the integral from 0 to 2 of that mess up there is going to be the same as the integral from 0 to 2 of g of x dx minus the integral from 0 to 2 of f of x dx. So I can split it up. So I can find the integral from 0 to 2 of g of x, and then I can subtract the integral of f of x. And so let's make g of x pink right there. That area is going to be this entire bit, these vertical pink lines, going between x equals 0 and x equals 2. Notice we're going from the positive y-axis to that intersection point there at 2, 4. So the pink area is going to be that interval. I keep saying interval. Integral. And that is a trapezoid with a base of 8 and another base of 4. Divide that by 2, multiply it by the height, which is more kind of better to be thought of as the width in this case, which is 2. And so, hey look, multiply by 2, divide by 2, and so our answer is just going to be 8 plus 4, which is 12. Now let's subtract away this other area. Let's make it purple for the area beneath the curve of f of x between 0 and 2. Well, that's going to be this purple area right there. So if we subtract that area away, to figure out the area that's left behind, which is going to be this squiggly green triangular area in there. So, if we want that purple area, that's again a trapezoid. Base 1 is 3. Ooh, let's change that color. Base 1 is 3 plus base 2 is 4 over 2 times the width, which again is 2. And so we get 3 plus 4 is our answer there, which is 7. So then we get that green area. It's going to be 12 minus 7, which gives us an area of 5. Notice also that it is a triangle right there. We have a base here from 3 to 8 of 5, and we can see the height here right there is 2. So this area should be 5 times 2 over 2, which indeed also gives us 5. So again, multiple ways to go about this. Alright, one more same idea, except this time we are not given the graph. Find the area between the graphs of f of x and g of x given the functions f of x equals negative absolute value of x plus 5, and g of x equals the square root of 25 minus x squared. And we're looking on the interval of negative 5 to 5. So let's sketch this graph real quick. Let's sketch this graph real quick. That was super weird. So let's draw some axes right there. I'm going to go 1, 2, 3, 4, positive 5, 1, 2, 3, 4, negative 5, and I'm graphing a negative absolute value of x graph. It was not shifted left or right at all, but it was shifted up by 5, so let's go 1, 2, 3, 4, 5, and I'm going to get a point right there. And I know that the slope on the right side is going to be negative 1, and on the left side it's going to be positive 1, and I'm going to get this little triangle looking thing right there. It's going to continue down. We're not necessarily interested in that part though. So let's actually just get rid of those because it says interval -5 to 5. So let's just show that bit of it upside down, absolute value of x graph. And now let's sketch in this weird square rooty thing. But remember, that is just the equation for a circle right there, the radius squared. And so that is telling me that the radius here is 5, which means I'm going to get a semicircle with that same endpoint right there, that same point up top, that same point right there, going to curve up and look like that. So I'm trying to find the area between the graphs, which means I'm looking for this green bit right there. So think about what I need to do to find that. Well, I need to take the area of that entire semicircle, and I need to subtract away the area of that triangle, which is that absolute value of x graph right there. That will give me the area in between those two graphs. So in integral notation, what I'm saying is I want to find the integral between -5 and +5 of, I want my pink function, which is g of x, minus my purple function, which is f of x, and I'm integrating with respect to x. And I could substitute those actual functions in if I wanted to. I could write it as two separate integrals if I wanted to. Plenty of options here, but that gets the job done. So let's find that pink area. Pink area, again, is going to be pi r squared. Radius is 5, so let's say 25 pi r squared, but it's a semicircle, so over 2. And we're going to be subtracting away that purple area, which is a triangle with a base of 10, and that same triangle has a height of 5 right there, and so we're going to get minus 10 times 5, base times height, over 2, and that will equal this green area. So I have 25 pi minus 10 times 5 is 50 over 2. And that is that area right there, 25 pi minus 50 all over 2, which I can approximate to roughly 14.27. So then, last idea, let's find this, whoa, I got tripped up by the word following for some reason. Let's find this one last definite integral, the integral from 0 to 2 pi of the function cosine of x. Well, let's think of the graph of cosine of x. Let's think about what that looks like. So, let's draw my axes here. Let's remember what we did in our trig unit. 2 pi, pi over 2, 3 pi over 2, positive 1, whoa, positive 1, and negative 1 right there. Cosine starts at its maximum value, then it hits 0, then it hits its minimum value, then it hits 0, and then it's back up at its maximum value. So if I sketch it in, it looks something along these lines with perfect symmetry there. So if we're finding the integral from 0 to 2 pi, we're finding this positive area right there. Boop, 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 boop. And then we also have this negative area right there. Now, I couldn't really draw this perfectly to scale, but if you think about the symmetry of this function, you should know that each one of those little sections has the same area. It's just a matter of, is it positive or is it negative? Well, we've got two of those little quadrants that are positive and two of those little quadrants that are negative, so this definite integral right here is definitely going to be 0.